we'll get it started off with something easy. I'm just curious, you guys get to see what a lot of people build with Flink. Just curious if you have like a favorite thing you've seen somebody in the community use Flink that you thought was maybe unexpected or really cool. Yeah.
Yeah, one of the use cases that I find still pretty amazing is the use case that DriveTribe is doing. So they had a talk here. They have been presented their use case for quite some time, but I still think this is a very great example of how to build event-driven applications. So in short, what they're doing is they're building the back end of a social network based on Flink, based on this principle of event-driven applications, being able to replay the history, being able to take a save point, do A/B tests for certain things that they want to improve. I think this is a very good example of how to do like a new kind of applications, right? So not being traditional stream processing, real-time analytics style, but more, event-driven applications.
For me, what maybe is a bit boring, but what I find interesting is these companies that provide Flink as a service within the company. So we've seen 3 companies in the morning present what they're doing, and it's basically teams within those companies providing Flink for other people to be easy to use. That's what I find very interesting, personally.
For me, it might also be a bit boring, but like coming from the engine, I'm actually always impressed by the scale Alibaba wants Blink actually, and that it's Blink, but still Flink as the basis, and that it scales to so large numbers is it's good proof that Flink is doing a good job.
Hi. I'm talking about stream-to-stream join. Let's say a single Flink job consumes 2 Kappa topics. If one Kappa topic, the data comes late, so the watermark will be behind. How does the Flink handle the watermark alignment? What does it do now, and what do you plan to improve in the future?
So so Flink basically requires that the watermarks of both streams are aligned. And if they're not aligned, then the part or the data of the stream that is ahead in watermark will all be buffered in state. So in the join implementation that is used by the stream SQL or by the SQL implementation, you'll simply see an increased state. And then, once the watermark basically reaches, once you basically have to buffer up all the data that one stream is ahead in time, and there's not really, at the moment there's no way around that. In the future, one could think of having sources that somehow communicate with each other to not ingest their data into Flink yet. And somewhat sync the sources on the current watermarks, but this is not there yet.
I think one solution, or what a buzzword is time-based back pressure, which will, in the end, there will have to be some way that operators not only back pressure because they're slow, but there should be a communication channel which propagates upstream that this operator is not yet at a time in event time where it should receive data at that time point, and then it propagates that information upstream where it at some point gets to the sources, and then the source would slow down. But as Fabian said, this is not currently in Flink, but the solution will end up having some properties of that. And now here.
Yeah, maybe just one comment. I think Alyosha is actually, like Alyosha's idea, I think is a great direction. Like you apply back pressure not just on actual like slowness of nodes, but you take event times queue into account. So previously, if you think of how applications were running Flink, back pressure is something that you do if you have to, but you should avoid it if you don't have to, right? Because as soon as you have back pressure, you start to have like slower checkpoints because the checkpoint barriers have to go through back pressure and so on. So one of the things that was mentioned like 2 or 3 times here now that is coming up in the 1.5 release is this whole rework of the network stack to this proper credit-based flow control. So one big reason that might not yet be really obvious why we're doing this is that it is a building block for actually doing checkpoints through back pressure, right? So that you can actually do checkpoints even though the data channels are stalling, because they're not really stalling anymore. You just change the way you're negotiating credit. That sounds like a small thing, but it's actually a really big thing, because it will allow us to actually apply back pressure and still have a very well behaved checkpoint behavior. So you could, for example, think of applying back pressure exactly for event time. It was something that before 1.5 we just couldn't do because it would mess with all checkpoints and so on. And that's why we've invested in this sort of seemingly esoteric thing, like why would you do a credit model in the network stack? TCP kind of does something similar for you like that. Yeah. So this is where it kind of all comes together.
If you have a question, just raise your hand.
Thanks for the conference. I've reached out to a few of you already. I know the theme of the conference has been streaming, real-time, all that. But actually, our use case mostly on the dataset API. So I just have a request that not to ignore that. And there are some use cases, at least I haven't figured out how to map them to a streaming yet. The day that happens, maybe I won't bother you, but not to ignore the dataset APIs as well. I mean, whatever you guys have in mind, so prioritize that.
That was a question? Okay.
That's a yes, okay.
Yeah, so one thing that we're looking into in terms of batch processing is driving forward this unification of batch and stream processing that we've been discussing for quite some time now. Right now, these APIs are still separate. They're running on the same low-level API, but using different techniques for the operators internally. One thing that will, I guess, start like in the next months is to really look into like how can we unify this from an API point of view, but also how can we integrate like the very mature technology that we have for the batch processing into stream processing jobs. There are a couple of things to do on that side. One of those is probably also somewhat redesigning how we ingest the data, having a way to have data sources that can consume batch data, or unifying the interfaces for consuming bounded data and unbounded data. So this is would be one step in that direction.
So for these batch sources that are bounded, like in dimension tables we refer to in batch, and you were showing us a sample in your SQL talk. Is the data from the batch source going to be cached, or is there going to be you're going to the data source for every single event in the stream? Like if I was joining a stream source with a batch source, for every single join, am I going to the data source, or is there a cached copy?
So this, well, kind of like depends on, so usually what we would do is we would like, probably like the first approach would be to load the data into Flink state. Having a way, if a source is declared as bounded, as finite, we would first read the data into Flink state and then join it with the stream that comes along. If you're in your use case, this data would be too large to be loaded, or so large that it wouldn't be reasonable to be loaded into Flink state. One can also think about having a special type of source or table definition. that can be queried with point lookups. So both is, I mean, from a SQL point of view, this is pretty well hidden from SQL, right? So you can define a table and you just give a definition of a table, and how this is then implemented depends on the back end. For instance, when you're using a regular database system, it also makes a difference whether you have like configured an index on the table or not.
Okay, two silly questions. If you could drop whatever we're working right now, what would you like to do on Flink? And what's the piece of Flink that you look at it and it really pisses you off?
For me, it would definitely be schema migration, if I can drop everything. Because schema evolution and specifically migration is is a big issue that some of our serious production users are facing into. And schema, as application developers, you would expect to work on schemas, and as your application grows, your schema would grow. So it is something that is very practical and you will bump into eventually. So this is something we should definitely, yeah.
I guess I'm boring again, but for me it would be testing would be the overall thing. So both improving the automated testing that we do for Flink releases, for example, so that we can do more streamlined Flink release processes, but also providing means for people to test the code that they write. So testing custom operators, so there's some stuff where you can do that. Had a session about that yesterday. Also providing means for testing user functions, providing means for testing the pipeline as a whole in unit tests or integration tests. Because that is something that most people should be thinking about, but might not be thinking about enough. But if Flink provides the right primitives and ways of doing it, that would be very helpful, I think.
For me, it's actually a continuation of what we started with Flip 6 to finally add proper support for containerized environments, because more and more people want to deploy it in such a way, and at the moment it's not I mean, it's working, but there still has some limitations which could be working much better.
Yeah, so for me, if you ask me what I would like to do, I guess that would be working more on the batch processing part, because I think Flink has very good technology on that side as well. If you ask me what should be done, probably improving the documentation would be a good thing to do as well.
Sorry, I didn't find a chair. Otherwise, I'd okay. I think I would almost like to say two or three things that I'd really like to fix over time. The first one is, I think when we started this whole thing, we didn't pay enough attention to making the dependencies as narrow as possible. So, for example, there was, when it started out, Hadoop was a big thing in that space, and we wanted to make it work seamlessly with that together, but we didn't pay enough attention that Hadoop just pulls an insane long tail of dependencies, and had we should have just like banned it to a separate class loader early on and said like, okay, whatever Hadoop pulls in should never spoil the class space of any other application. I think we should have done the same thing with Scala in the runtime, so that Scala is a pure API thing. Like in the runtime classes, or in the classes that you see if you use the Java API, like all Scala stuff that the runtime uses for akka for coordination, just confine it in a separate class loader, get it out of the way. Like just do more modularization on that level, and that is one thing. That was almost also the second thing I would actually like to think of, the whole class loading, dynamic class loading, less dynamic class loading, or at least making it more explicit for users how this whole thing should behave. Like when should it actually when should different operators actually load their own copies of classes versus when they should they not do it? Just make this more explicit, more configurable. Maybe change the defaults there a bit. It's a hard thing to do now because it implicitly breaks a lot of deployments if you start doing that. And I think the third one would be, in addition, I mean, these guys said very good things, right? So I'm trying to come up with something else now. Like, it's probably not the most important thing, but having, let's say, like schema migration and testability and all of that covered, I would really like to take, maybe with some amount of time, another take at the serialization stack, because especially in cases where you run, for example, with RocksDB, one of the really important things is being able to move data off heap and on heap extremely fast. On the batch side, when we started out Flink, we had a lot of work into this, like operating on binary data. So like the sort buffers, the hash tables, and so on, they wouldn't actually deserialize data. So the serializers were something, they had to be good, but because a lot of the heavy work wouldn't actually use the serializers, but directly operate on the binary data, it was okay. Now that every record, that every time you access state, you have to go off heap on heap with RocksDB. Certain things just become even hotter than they were before, and I think there's a bunch of lessons that we also learned into, like how would we actually do data layout in some of these composite serializers? How would we do encoding to maybe have a byte written more here rather than less, but save a few CPU cycles and not doing compact var length encodings and just like gain a bit of speed on the way or so. I think that could for some of these deployments give you like a very significant speed up. The problem is why we're not doing this is that unfortunately the serializers are part of backwards compatibility. If you actually have a checkpoint or a save point and you change the serializers, you'd have to have an elaborate piece of migration in place. And schema evolution is putting the blocks in place to allow us later to actually start messing with the serializers, because you can actually evolve internally from one to the other and so on. So again, there are a few pieces coming together.
There's a question?
Hello. So we deploy on Amazon, and this isn't necessarily a Flink question as opposed to an Apache question, but as you know, there are two big pain points. One is that the Kinesis connector library has a non-Apache compatible license, meaning everyone has to build their own components there. And the second is that Amazon's EMR trails Flink releases by sometimes many months. And I was just wondering if you have dialogue with Amazon. Do you have any ability to pressure them on either of those, or just one of those, well, they'll do what they do and we have to live with it kind of things?
Do you have something? Actually, one of our colleagues, Robert, he has contacted with Amazon initially with the licensing issues, but I'm not sure about how closely Amazon EMR follows the version releases. But regarding the licensing issues, maybe Robert, if he's here. If not, we can also talk about it afterwards. Yeah. Does that answer your question? Okay, thank you.
Hi. So out of all the talks we had today, is there something which you really liked, you'd like to take in-house? For example, for Alibaba, the rebalancing which they do, that was very impressive. And secondly, in, let's say, DA dashboard right now, I'm not sure like you mentioned or not, but if we have something like auto-scaling which scales up or down, so is there something you heard today in any of the talks which you would like to take in-house?
Can you repeat the last sentence, please?
So is there something which you like that it will be implemented in Flink itself and packaged? For example, Alibaba does very fancy rebalancing, which I think will be very useful. So something like that.
I think what you're talking about is what Alibaba experienced, that when you have some data skew and to deal with that, right? that they have something like they can change the partitioning function of the key groups. Actually, I talked with Haitao about that in the morning, and he said that this is actually one of the features they could also imagine to contribute back to Flink. And actually, Alibaba has moved, I mean, quite closely to the Flink master, and they are constantly contributing things back. Like, for example, the one of the big changes in the network stack, the application level flow control, is one of their contributions, which is really awesome.
Yeah, I found a talk on bootstrapping state quite inspiring. Also, I mean, I know this is hard, but like also being reminded of what are the different options and why they don't really work so well. Was really good to think about again, and having a feature that would allow to basically populate state that then later can be served as a basis for a streaming application seems like a very useful feature to me.
Anything else? Any questions? Be brave. You can ask anything. All right.
So have you thought about Java 9 or plans for adopting some of the new features in Java 9, or would it affect Flink at all? Java 9, Java.
Well, the mic was. Did you get anything?
Java 9.
Yes. I didn't get the complete question because I think the mic was turned off, but was it about whether we would be supporting Java 9? Was that the question?
It's a bit of an open question. I mean, I just thought if there were anything in Java 9, the new features in Java 9 that you thought of making use of on the Flink platform, the packaging, you know, anything.
So the problem is a lot of people are somewhat slow in adopting new Java versions. So in Flink, we usually are lagging quite a bit behind what is available. So I was a bit surprised when I learned that Java 10 was actually released, because we only somewhat recently moved from Java 7 to Java 8, because there were quite a lot of people that were still on Java 7, so we wouldn't move. And I think the same is going to happen with Java 9, where Flink is going to stay on Java 8 for quite a while, I think. So I'm not aware of, I'm aware of Java 9 features, but I'm not aware of what or when or how we're going to make use of that.
I just have a question. So with the release of DA platform, now there's sort of with the application manager, a piece of Flink that is a pay-for product. I'm just curious how you guys as a company sort of view the guiding principles of where these things live, right? We have certain things where it's kind of an open core and you get some features that really that would hopefully be an open source thing that aren't. I'm just curious kind of how Data Artisans views that decision.
Sorry, they gave me the mic because that's a business question. Sorry, the question was what goes to open, what goes to...
Like if there's something that sort of lives between the world of, okay, is this more on the application management side that could theoretically be in Flink, or is it something that would end up in sort of the DA platform or the application manager, for example? How do you guys view that decision-making process of kind of where that goes and where that lives, and how whether that gets open sourced or lives in DA platform?
Yeah. So it's tough. Yeah. In theory, everything can be open source. In theory, everything can be closed source. So I think the challenge here is to strike the right balance. We definitely don't want to cannibalize on Flink. So what we definitely don't want to do is offer, stripped down versions that are open and something that is actually usable, that is closed in general. The way we've been thinking with DA platform and application manager is that, and at the same time, making everything open source just enlarges the scope of the open source project without any particular reason, right? So there's no particular reason to just shove everything into Flink. So I think it's a delicate balance. So with application manager, we've been thinking about Flink as a stream processing engine. You give it a job, it runs a job in a distributed setting. And when you go like one level beyond that, interactions between jobs, the life cycle of a job, et cetera, put that in application manager. What the future will bring, remains to be seen. Yeah, but in general, this is sort of our thinking, like core engine, open source, lots of tooling to bring everything, to a production setting and organization in our product. And I think this is becoming like, in the business world, something increasingly acceptable. A successful open source project also needs to have successful business backers behind it. And the way that we believe to build a financially successful company is with this open core model. So yeah.
More questions? I think the beer should be cold by now. Thanks for your questions, and have a great Flink Fest.
Thank you.